Hi everyone, my name is Amitesh, and in this video we're going to explain how do you find that quantity over there. It's the square root of 1 plus the square root of 1 plus the square root of 1 plus so on and so forth. So this looks like some crazy expression. We're going to actually figure out that this is a concrete number, and we're going to explain how you actually find it out. And in a future video we're going to explain why our methodology is justified. Because what we're going to do here will be some kind of magic, but it has to actually be explained through rigorous mathematical reasoning. But let's dive right into it. And I want you to first think about what you think this sum is. How would you go about finding it? It's kind of a crazy expression. And what does it even mean to actually understand this expression, right? So I'm not even going to talk about what it means. I'm just going to first explain how we're going to try to find it, and we'll sort of get a feel for what it means while we're doing that, okay? So what we're going to do is we're going to call this number x. Okay, in math, you don't know what something is. Let's just call it something. Let's call it x. Now, once we've got x, we want to figure out what x is. And that's the challenge for you. So my hint to try to get started with this is, what is x squared going to be? This is my hint. If we know that that is x, what happens if we square x? Do we get something similar to x back? That's the question. So I want you to pause the video, leave a comment down below. What do you think x squared is, and how you might use that to find out x? And I'm super excited to read your comments because there's so many different ways of looking at it. But I'm just going to dive right into it now and say the way I think about it is, what happens if we square x? So we know that x is this kind of what is called a nested radical. It's just root of, etc. Right? So if we square a root of something, we're just going to get back, just remove the square root, right? So x squared is going to be 1 plus the square root of 1 plus the square root of 1 plus the square root of 1 plus dot dot dot. Now here's the really cool kind of magical thing here, is that this thing, square root of 1 plus square root of 1 plus square root of 1 plus dot dot dot, it's just x. It's just x, because when you look at x, x is just square root of 1 plus square root of 1 plus square root of 1, etc. The key thing is you're doing this infinitely many times. So if you're just doing it one less than infinitely many times, it's still infinitely many times. So that kind of magical property implies that x squared is just the same as 1 plus x. And now we use math. So this is where quadratic equations and the quadratic formula becomes really cool. We just now need to solve this equation in x. So assuming we've studied, we know how to solve this quadratic equation, we can write this as x squared equals 1 plus x, or equivalently you can write this as x squared minus x minus 1 is equal to 0. So you've just got that, x squared minus x minus 1 is equal to 0. And now it's a quadratic equation, so let's just use the quadratic formula. The quadratic formula is telling us that x is equal to minus 1 plus or minus, because there are going to be two solutions. And that's the other kind of crazy thing here. How can there be two values of x? I mean, x is just going to be something, right? But let's actually check this out. So it's going to be minus 1 plus minus, or I should say plus 1. So it's going to be minus of minus 1, so the minus 1 coefficient of x, plus or minus root of 1 minus 4 times the first coefficient times the third coefficient. So it's going to be 1 minus of minus 4 divided by 2. Okay, so assuming you've seen the quadratic formula, you've got this, and this is going to be, and I've done videos on the quadratic formula. Any relevant videos, links are down in the description below. Okay, but there is this formula. Even if you haven't studied this, you can just accept there is this formula. And the answer is going to be 1 plus root of 5 over 2. So that's going to be what x is. So there are two solutions for x. But what's going on here? I mean, what are these solutions really? So let's just check that out. So square root 5, well, we know square root 4 is 2. We know square root 9 is 3. So square root 5 is going to be roughly between square root 4 and square root 9, right? It's going to be exactly between them. But that's going to be between 2 and 3. Okay, so therefore, if we know that, what we can do is we can say, so I'm just going to put this here, we can now write that square root 5 is between 2 and 3. What is 1 plus square root 5 over 2 going to be? Well, it's approximately something between 2 and 3, right? So 1 plus square root 5 is going to be something between 3 and 4. And if you divide by 2, so we can kind of do this in steps, 3 is less than 1 plus square root 5 is less than 4, or equivalently 3 over 2 is less than 1 plus square root 5 over 2 is less than 4 over 2. So now what you've got, so I'm going to erase this now that we've got this expression, we can now say that that quantity there, 1.5 is less than 1 plus square root 5 over 2 is less than 2. It's some number between 1.5 and 2, but it's closer to 1.5 than it is to 2. This is actually a very famous number. It is called the golden ratio. And it appears everywhere in nature, in mathematics. It's what is kind of related to aesthetics, in symmetry, in art. So there's a whole lot about this. I encourage you to Google the golden ratio. I'll definitely do more videos on it. And if you're watching this video a little later, links of all relevant videos down in the description below. But this is what is called the golden ratio. But what happens if, and people denote it by this Greek letter, which is phi. But what happens if you take the other solution, which was 1 minus square root 5 over 2? Well, because the square root of 5 is greater than 2, 1 minus the square root of 5 will be a negative number, because 1 minus something greater than 2 is negative. So this is actually going to all become a negative number, and we can actually cancel, we can rule this out as a solution, because that, whatever number that is, whatever you can conceive it to be, it's most definitely not negative. It's something positive. So you can therefore conclude that the answer for this whole problem, so I'm going to now write it down. So let's kind of erase this all off. The answer is just going to be equal to phi, which is the golden ratio. This very famous number in math, that is what the answer is. Now, there's a lot of stuff going on here that I've swept under the rug. So if you're doing rigorous math and you're coming to this video, you'll probably think about sequences, convergence, series. There's a lot of fancy math that goes behind why this is true, because I can do the same kind of magic with another sum or another kind of infinite thing and get something nonsensical. Okay, so here's what I'm going to do. I'll show you this, and you'll see that this is why we have to be ultra careful with this stuff. Because what I can do is, I can write down the following. So I'm going to do it on this side of the board. Let's kind of start off by talking about the following: 1 plus 1 plus 1 plus dot dot dot. What is that going to be? Now, we know that's infinity. That isn't a number, right? We know that because we know it keeps getting bigger and bigger and bigger. However, let's try to do the same methodology. Let's call this x. Okay? Now, what I'm going to do is I'm going to ask you, what is x plus 1? What happens if I take x plus 1? Same kind of idea here, okay? If I take x plus 1, I've added a bunch of infinite number of 1s. If I just throw in another 1 to that, it's just the sum of a bunch of infinite number of 1s. So x plus 1 is just going to be the same as x. However, if we now say that x plus 1 is x, and we cancel x off on both sides, trying to solve an equation, we're going to get that 1 is equal to 0. So this is like one of those false proofs. There are lots of them out there. Why is 1 is 0? That means you've done something wrong at some point. And the thing we've done wrong here, well, what's the thing we've done wrong? What do you think we've done wrong? Drop a comment down below. I'd love to see it. But my way of looking at it, the thing we've done wrong is we've added a bunch of things. We've called it x. Well, x is infinity really. And when you have something like infinity plus 1 is infinity, you can't really solve for infinity there. You can't, this is kind of illegal, because this kind of approach relies on the fact that x is some finite number. So if you know that x is not a finite number, it's illegal to do it this way. And this is why in this approach here, we have the same question. Someone can ask, how do we know that if we keep on doing this long, complicated thing, how do we know that we're not getting something that is infinity? And if it's infinity, then we certainly can't say it's 1 plus root 5 over 2. That's going to be the topic for another video. but I want you to think about it. You know, drop a comment down below. I'd love to see, why do you think this whole thing, why do you think it should be something finite and not infinity? Okay? And one kind of way of looking at it is, how do we even define this? I mean, what is it really? Like, we could sort of add up the bunches of ones and we could sort of say, okay, that's, you add one to itself twice, then thrice, then 4 times, and it keeps getting bigger and bigger, and then it sort of eventually becomes so large. So we say that eventually, if you're adding an infinite number of them, it's going to be infinity, right? In the same way, suppose I did something like, in this situation, suppose I just kind of did it step by step. I took square root 1, then I took square root 1 plus square root 1, then I took square root 1 plus square root 1 plus square root 1, then I took square root 1, you're going to see the pattern here, 1 plus square root 1 plus square root 1. You see that we keep doing the process more and more times. Eventually, this number is going to approach something. And that's the question. Does it get really, really large? Or if it doesn't, then how do we know it approaches 1 plus square root 5 over 2? Okay, so that's going to be the question of this video. Drop a comment down below. And if you've watched this far, it really means a lot to me. I'd love it if you could leave a like and subscribe. It only takes a second. It means a lot to me to make these videos. And by liking and subscribing, you're helping me to achieve my goal, which is a worldwide, universal goal of just making math free, accessible to everyone worldwide, so they can really appreciate it, be inspired by it, love it. And just by watching my video itself, you know, you've done a lot to support me. So thank you so much for that. And I'm super excited to see you in the next video. And you know, links of relevant videos are down in the description below. You'll see a link once it's up of the sequel, which should be very soon at the time of this video. So of explaining the real rigorous math behind why this works. And I want you to think about that first. And in the meantime, I hope that I've supported you and wish you all the best. And please take care. And I'm super excited to see you soon. Thank you so much.